Yo, 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 chicken, yo, Samichi, yo, here, aspiring C-Rap artist, here in place of Canu to give you the overview of Chapter 12. All right, guys. For Chapter 12, basically, we talked about the idea of solutions. And you have two basic parts of solutions. You have the solute, you have the solvent. The solvent is what does the actual dissolving. Examples of solvents would include things like acetone and water, which you don't put in a metal cup and put in a microwave oven. I learned the hard way. Yo, 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 check it. The solute is what's actually getting dissolved. Now, a lot of people don't realize it, but think about cocoa powder. Think coffee, okay? Think about if you ever had to put Alka-Seltzer into a glass of water. Those would be wonderful examples of solutes. Okay? Now, at some point, typically solutions, they're going to involve water. And water's got that unique property. It's got hydrogen bonding, you know, where hydrogen hooks up with fluorine, oxygen, nitrogen. It's a very tight bond. We talked about intermolecular forces in the past. Okay? But here, looking at with water, with the hydrogen bonding, acts like a thermostat for the planet because it helps keep the planet, if you think about it, not too hot, not too cold for life to exist. That's a big thing. Now, we also got to talk about, as we're pulling away from water, we've got to look at the idea of solutions and concentration. That would be a pretty important concept. There are different ways to look at concentration, but the one that we focused on this semester is something called molarity. But what is molarity? Well, molarity is moles divided by liters. That is our basic formula for molarity. Now, we tend to represent it with the big letter M, okay? And with that, we can have an idea about concentration, like the difference between, let's say, 0.5 molar and 5.0 molar. Which one of these is more concentrated? It's the 5 molar. So the bigger the number, the more concentrated it is. Let's think about it another way. You go to In-N-Out, you get your soda cup, you go to the machine, okay? You go, put a little bit of ice, then you put in the thing in the machine, okay, and you drink it and you find, wow, this thing is not sweet at all. It doesn't even taste like soda. It just tastes like, ugh, that's soda water. And that's probably a low concentration right there. On the other hand, you go back, you empty it out, this ice and all that soda, you go back, you go to the other machine, put some ice in there, put it in for the soda, okay? And then you drink it and you find, hey, this tastes better, this tastes like real actual soda. That would probably be your higher concentration with that. You know, when we talk about polar and nonpolar molecules, you know, especially for something like water, you know, what's going on with the ability to dissolve? Remember, the ability to dissolve is a question of positive connecting to negative. The positive of one molecule A connecting to the negative side of molecule B and pulling it apart. Okay? That's the basic idea, whether it is covalent bonding or ionic bonding. Okay? Now, what about polar and nonpolar? Well, remember the idea behind polar. Okay, if you think about polar, water is a beloved polar molecule. Well, why? Well, because you got the negative ends there and you have the positive ends here on the hydrogen. So that means if it goes on, it will pull on things that either have a positive or a negative end to it. And that will allow the breaking apart of things. But what if it's something that is non-polar? Well, if we look at something like this, this would be an example of a nonpolar molecule. Now, I'm not asking you to identify polar or nonpolar molecules. What I am pointing out to you guys, if you only have a molecule that's just all positive on the outside or all negative on the outside. That's not polar, okay? That makes it a lot harder for water to be able to go in there and pull the thing apart, okay? And when we look at nonpolar stuff, think things like oil. Water doesn't mix with oil, right? Hey, how about that vinegar and oil salad dressing? Okay, what's up with that? Well, vinegar is mostly water. And water doesn't hook up with oil because water is polar and oil is nonpolar. Chicka, yo! Okay, so that's some of the ideas there. Let me see. Did I use molarity? And yes, I would expect you guys to be able to solve molarity problems. Okay, and for that, you can check out the Grandmaster CEO's videos out there on Canu's ChemCore YouTube channel. All right, this is Sammy G.O. increasing the street cred for my upcoming C-Rap career.
Peace.